Welcome to the Lingua Loom. Today we'll be discussing government and binding, which is the next step of pre-GB. So let's start. By 1980, transformational grammar had piled up rules for decades, enough to confuse even the most brilliant minds. Everywhere you look, there are rule books, thick, messy, overflowing with dozens of transformations: passive rule, raising rule, dative shift rule, extraposition rule, tough movement, reanalysis, WH movement, buried movement rules inside subrules of subrules. Syntax had become, well, a jungle. Everyone knew the rules worked, but the system was starting to feel like a machine with too many screws. It was getting too complicated, too artificial, too far from what a child could possibly learn. Chomsky envisioned a system where the mind's own machinery could explain language, rather than endless external rules. So he proposed something bold. What if all languages share the same deep principles? What if children only set a few switches? What if transformations are not many, but one? Then came 1981, the year syntax had its quiet revolution. That's when Chomsky published Lectures on Government and Binding, the work that unveiled a new, elegant architecture for understanding language. He said, in essence, stop piling rules. Look for the universal principles. Let's discover the mental machinery that makes all languages possible. This changed everything. Universal grammar, UG, and principles and parameters. Chomsky's vision began with universal grammar, UG, the innate set of structural rules that all humans are born with. UG wasn't about English or Japanese, it was the hidden blueprint behind every human language. GB is essentially a realization of UG in syntax, showing the machinery that builds sentences. Within UG, Chomsky introduced the revolutionary idea of principles and parameters. Principles are universal, every language obeys them. For example, the theta criterion ensures that every argument in a sentence receives a proper role. Parameters are switches that vary between languages. Consider the pro-drop parameter. Some languages, like Italian or Spanish, allow the omission of subjects, pro, while English requires explicit pronouns. This system explained why children could acquire language effortlessly. The principles guide them, and exposure flips the appropriate parameters for their language. With these switches, UG can generate all the diversity of human languages while remaining grounded in the same deep structure. Chomsky's insight here was profound. The mind is not a blank slate. It comes pre-equipped with a system designed to generate infinite expressions. Now let's discuss core grammar versus marked periphery. GB divides grammar into two zones: the core grammar, which contains essential, universal mechanisms, and the marked periphery, which is optional, language-specific, and variable. Core grammar is determined by UG and parameter settings, while the marked periphery consists of language-specific rules, exceptions, and borrowings that fall outside the parameterized core. Levels of representation: D structure, S structure, LF, PF. In GB, a sentence isn't just a string of words. It begins at D structure, the deep blueprint, where verbs assign roles and meaning is seated. Here, each argument is in its base position, and every verb assigns its theta roles: who does what, who experiences what. For example, in the sentence, John seems to like Mary. At D structure, John originates in the embedded clause as the experiencer of like, and Mary is the theme of like. The matrix verb seems assigns a theta role to its clausal complement. The sentence is still in its deep, abstract form before any movement occurs. Next, it moves to S structure, where phrases shift to satisfy grammatical requirements. In our example, John moves to the surface subject position to check case, and any traces of movement are left behind. This is the stage where the sentence skeleton starts to resemble what we recognize as a proper sentence, with all necessary movement accounted for. John seems to like Mary. Here, TI is a trace marking John's original position. PF, phonological form, then translates this structure into sound, what we actually hear. It handles word order, stress, and intonation. John seems to like Mary. Finally, LF, logical form, interprets the sentence. LF resolves meaning, traces, binding, and scope. It tells us who is experiencing what, who likes whom, and ensures the semantic relationships are clear. In our example, LF shows that John is the experiencer of the seeming, and Mary is the one being liked. It's like watching a factory at work, planning, then assembling, moving to speaking, and finally understanding. Every stage is crucial, precise, and layered. Together they make human language not just possible, but elegant and interpretable. Every sentence flows from the lexicon, through X-bar projections, into D structure, then moves to S structure, before splitting into PF and LF. Now let's discuss what GB introduced. It gave the new architecture. GB didn't give one big rulebook. It gave modules, small, specialized departments inside the brain's syntax factory. GB says the mind has separate mini-grammars, each doing one job. This structure made grammar feel biological, not mechanical. The modules are theta theory, case theory, binding theory, bounding theory, government theory, X-bar theory, control theory, trace theory, move alpha, ECP. Let's deep dive into the modules. A. Theta theory, who does what? Every verb is like a mini-drama with specific roles. Some verbs require an agent, the doer. Some need a theme, the thing affected. Some need an experiencer, the feeler. Some need all three. Example. John, agent, opened the door. Theme. Theta theory says, every argument must get exactly one role. Every role must be assigned to exactly one argument. This solves. Why John sleeps Mary is impossible. Why the broken window fell the boy makes no sense. Why verbs control the number and type of NPs they allow. Behind every verb or noun is the lexicon, the brain's dictionary of meanings and requirements. Each verb carries a subcategorization frame, a specification of what arguments it needs. For instance, GIF expects a subject, a direct object, and an indirect object. This ensures that when we build sentences, every argument has a role, and no one is left floating in the wrong spot. This is all fixed at D structure. B. Case theory, who gets case? Languages have invisible case. Even if you don't see it, your brain insists on it. English. Nominative is subject, I, he, she. Accusative is object, me, him, her. Case theory says, every overt NP must have case. This is the case filter. This explains why him cannot appear as a subject, why he saw I is impossible, why certain positions force movement to get case. Case is assigned by, finite T assigns nominative, verbs assigns accusative, prepositions assigns oblique. Example, her likes he. It's wrong. Both NPs have wrong case. Case theory predicts this. C. Binding theory, the dance of reference. Binding is about who can refer to whom in a sentence. Binding theory ensures that pronouns, reflexives, and names interact correctly. 3 categories. A. Anaphors, himself, themselves, must be locally bound. John saw himself. Is correct. Crossmark himself saw John. Is wrong. No antecedent in the right position. B. Pronouns, he, her, them, must be free in their local domain. John thinks he is smart. Is correct. John praised him. Is wrong as it violates B, C. Our expressions, John, Mary, must be free everywhere. He likes John. Is wrong as it violates C command, local domains, and governing categories explain how this works. S consists of NP and VP. John comes under NP. VP consists of V-bar, which consists of V which is saw and NP which is himself. John C commands, himself, here principle A satisfied. D. Bounding theory, movement limits. This module says, movement cannot jump too far. 2 main bounding nodes, NP, CP, formerly S-bar, movement must be local. Example, what did you say that John bought? Is correct. What did you hear, the rumor that John bought? Is wrong. Too many bounding nodes here subjacency violation. Bounding explains why WH movement has limits. Why islands block movement. Why long-distance movement is rare. Movement isn't free to go anywhere. The nominative island condition, NIC, says nominative subjects form islands. You cannot extract them freely. And the residue of NIC captures the lingering effects, small leftover restrictions that keep syntax precise and prevent ungrammatical leaps. The specified subject condition SSC adds another layer. If a subject is specified, carrying features like tense or agreement, it blocks certain movements. Think of it as a gatekeeper that prevents phrases from jumping over busy, feature-rich subjects. E. Government theory, the invisible wiring. This one ties everything together. Government is the structural relationship between a head and the positions it controls. A head governs, its complement, its specifier, sometimes inside its domain if no barriers interrupt. Government matters because case is assigned under government. Binding domains rely on government. Empty categories must be governed. Essentially, Government is the invisible wiring inside syntax. FX bar theory, universal phrase skeleton. Before GB, each phrase type had its own rules. X-bar theory unifies all phrases, stating, every phrase is built from the same universal skeleton. Specifier is the daughter of XP and sister of X. Head, X, is the daughter of X and sister of complement. Complement is the daughter of X and sister of X. Adjuncts is recursive. All phrase types, NP, VP, AP, PP, TP, follow this universal blueprint. The projection principle ensures that every word in the lexicon projects its features into the sentence. In other words, the requirements of a verb or noun are respected throughout the structure. So when give appears, its three required arguments are never ignored. The syntax honors the blueprint laid out in the lexicon. This changed everything. G-control theory, pro and infinitives. Infinitives have invisible subjects called pro. John wants to leave. Here, John is controller. John persuaded Mary to leave. Here, Mary is controller. Rules. Pro is controlled from outside. Pro does not get case. Pro cannot appear in overt case positions. Indexing theory helps keep track of who controls what. For example, in John hopes pro to win, it tracks that John is the controller of the invisible pro. It ensures pronouns, traces, and pro are all properly linked, so meaning flows smoothly through the sentence. Pro doesn't get case. Its reference depends on the controller. H-move alpha plus trace theory, the heart of GB. Before GB, separate rules for WH, passive, raising, etc. GB says, all movement is move alpha. Alpha is anything. When something moves, it leaves a trace, T. Example, what did John buy? Trace is crucial because it marks original position, allows interpretation at LF, ensures theta roles are satisfied, ensures case is checked. The licensing of these traces is itself governed by a central principle, the empty category principle, ECP. When elements move in a sentence, they leave behind a trace. But not every trace is allowed. The empty category principle, ECP, ensures that every trace is properly licensed and interpretable. It's like a safety inspector, checking that every empty spot left by movement makes sense for meaning and grammar. Trace theory unifies WH movement, raising, passives, etc. Movement is now elegant, general, universal. Configurational and non-configurational languages. So whether a language is rigidly structured like English, a configurational language, where subjects, verbs, and objects occupy predictable positions, or free-flowing like Warlpiri, a non-configurational language, where word order can vary and morphology signals grammatical roles, the mind applies the same core principles. Government, binding, case assignment, and theta roles operate universally. What differs is the surface configuration. In configurational languages, moving a subject or object can break grammaticality, kicked John the ball is wrong, while in non-configurational languages, the same sentence may be perfectly fine because case markings and morphological cues preserve meaning, John the ball kicked, is correct. GB provides the lens to see how these universal principles adapt to different surface structures, revealing the elegance of human language across diversity. This indicates that, regardless of the surface shuffle, the brain applies the same core principles to ensure meaning. Now let's close the discussion. GB made syntax modular, elegant, universal, learnable, biological, and predictive. It swept away complicated rulebooks and replaced them with a clean, interconnected system. It was as if a fog lifted, suddenly syntax looked less like chaos and more like a perfectly designed machine of the mind. This was the doorway to modern syntax, to barriers in 1986, minimalism in the 1990s, and everything we study today. GB wasn't just a theory, it was the moment syntax realized it could become a science. Visit our website for amazing related information. Thanks for watching. Like, subscribe and share.